Hi everyone, I'm Dr. Kiran Raavi, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. Today we are going to discuss N-channel enhancement mode MOSFET. So let us see overview of today's presentation. So we start with introduction to the MOSFET and what is the N-channel enhancement MOSFET in internal structure, and then construction and operation, and we'll discuss what are the different VI characteristics of MOSFET in enhancement MOSFET, particularly in N-channel enhancement mode MOSFET, and conclude with the summary. So coming to the introduction, so it is usually MOSFET is a family of FET or advancement of FET. FET is a 3-terminal device. The 3 terminals are gate, drain, source, and it has got 2 PN junctions. It is a voltage control device. FET is a unipolar device depending solely on either electrons or holes, and if the operation depends on electrons, then we can say it is N-channel FET, and if the operation depends mainly on holes, then we can say it is a P-channel FET. The charges present in the FET establish an electric field which controls the conduction path of the output circuit without the need for direct contact between the controlling and controlled quantities. So here in this, controlled quantities means drain current, and controlling parameters or output input voltage, that is gate to source voltage. So MOSFET stands for metal oxide semiconductor FET, which is classified into 2 categories: enhancement mode MOSFET and depletion mode MOSFET. Enhancement mode MOSFET is further classified into N-channel and P-channel, and depletion mode MOSFET is further divided into N-channel and P-channel DMOSFET. So coming to the construction of N-channel enhancement mode MOSFET. So in N-channel enhancement mode MOSFET, we have to consider first P-type substrate, and in P-type substrate, so the majority charge particles are holes. However, electrons also present in minority concentration, and we have 2 N-wells, and through these 2 N-wells, so there is a hole, through hole terminal D is formed. D means drain terminal is formed and source terminal is formed, and in between P substrate and these drain and source terminals, we have a SiO2 layer which is act as a insulator, and on the top layer we have a metal that is termed as gate terminal. A slab of P-type material is formed from a silicon base and is again referred to as substrate. The source and drain terminals are again connected through metallic contacts to N doped. So that means 2 sides we have N-type and N-doped regions. The absence of channel between 2 N-doped regions we can observe. So there is no channel. The SiO2 layer is still present to isolate the gate metallic platform from the region between the drain and source. So here SiO2 layer is still present to isolate gate from the drain and source. So coming to the operation of the N-channel enhancement mode MOSFET. So if VGS set to at 0 volts and voltage is applied between drain and source, so that is we are giving drain to source voltage and we are giving some VGS. VGS is first initially set to 0 volts. In such case, the source and drain terminals are again connected to the metallic contacts to N-doped regions. The absence of channel between two N-doped regions. The SiO2 layer is still present to isolate the gate metallic platform from region between the drain and source. It is not sufficient to have a large accumulation of carriers, electrons, at the drain and the source due to N-doped region, because end doped region there is no channel actually. So therefore there is no sufficient large accumulation of carriers, that is electrons, at the drain and source. So due to the end doped regions, and if a path fails to exist between the two, so if a path exists between two, means there is less chance of getting electrons there. So with VDS some positive voltage and VGS at 0 volts, what happens? And terminal SS directly connected to the ground. So directly connected to source. So source is directly connected to the body here, substrate body. And so in such case, so there is not sufficient to have a large accumulation of electrons. So there are two reverse PN junctions between the end doped regions and P substrate to oppose a significant flow between the drain and source. So this is the basic point here. So there is a two reverse bias conditions and less number of electrons there, and so there is a large depletion region between P type and N type when VGS is equal to 0 and VDS is some positive voltage. Now second case, when VGS is equals to greater than 0 volts. So if you increase the gate to source voltage, the positive potential at the gate will pressure the holes in the P substrate along the edge of the SiO2 layer. So the holes present in this will be attracted towards the gate because of the positive potential at the gate. So they reach towards the SiO2 layer. So in between gate and P substrates, we have a SiO2 layer which acts as an insulator. So to leave area and enter deeper regions into the P substrate. A depletion region near the SiO2 insulating layer void the holes. So there are removal of holes here near the SiO2 layer. The SiO2 layer and its insulating qualities will prevent the negative carriers from the being absorbed at the gate terminal. So here it is the gate terminal, and in between P substrate and gate terminal we have SiO2 layer, and this SiO2 layer acts as an insulator and its insulating qualities will prevent the negative carriers from being absorbed at the gate terminal. So here gate terminal is giving positive, right? So obviously it will attract the negative terminals, negative charge particles. So but SiO2 layer which opposes this process. The level of VGS that results in the significant increase in drain current is called threshold voltage and is given the symbol Vt. So Vt is threshold voltage. So it is the voltage between gate and source. And since the channel is non-existent with VGS is equal to 0 volts and enhanced by the application of positive gate to source voltage, this type of MOSFET is called enhancement type of MOSFET. So coming to the characteristics of N-channel enhancement mode MOSFET. So here if VGS is greater than 0, the positive potential at the gate will pressure holes in the P substrate along the edge of the SiO2 layer to leave the area and enter in deeper into the P substrate. Any further increase in VDS at the fixed values of VGS will not affect the saturation level of ID until breakdown conditions are encountered. So here you can observe the depletion region changes near the SiO2 layer. So if you observe the VI characteristics of this N-channel enhancement mode MOSFET, see here if the positive voltage is given, so the correspondingly the ID increases, and if you observe these points, so these points means, so when we increase the positive voltage, or we can, if you decrease the gate to source voltage, positive voltages, then obviously your pinch off condition occurs early of the VDS. So that means if you observe, this is the pinch off conditions. So when VGS decreases and VGS decreases means the pinch off condition occurs early, and this forms, you can observe this is the locus of VD set. So that means there will be a saturation in between drain to source voltage and at the same time you have a saturated drain current, that is IDSS. Okay, so this is the, so after pinch off condition, if you further increase the drains to source voltage, there is no increase in the current, so current is constant. The drain current, output current is constant. So by that way, so we can able to control the current, drain current, output current by changing the gate to source voltage. So this is about the construction and operation, and at the same time characteristics of N-channel enhancement mode MOSFET. So that's all for today. And today we have discussed introduction to the MOSFET and what are the internal structure of the MOSFET, and we have discussed particularly N-channel enhancement mode MOSFET and how it is constructed and its operation, and we have discussed the characteristics of MOSFET, enhancement mode MOSFET, that to N-channel enhancement mode MOSFET. So next topic will be probably P-channel DMOSFET. Thank you.